dear students, welcome back to my class. In the series of learning programming in C, in the previous video, we have discussed about wild pointer. Well, we'll proceed with few more topics on pointers. In today's video, we will discuss about how to return pointers from function. Well, we have seen how to return a string from a function. Well, there also we are using the pointer concept itself, but there we are returning a character array, in the sense string. But now here we'll see how to return the integer pointer from a function. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So here is the program to understand how to return a pointer from a function. So here we have a function by name retptr, means return pointer. Then I say I am returning pointer means the data type should be a pointer. What type of value I am going to return? That data type I need to mention, followed with a pointer symbol, that is asterisk. So I say integer pointer. Then I am passing array as the argument. It is sufficient if you just mention the subscript. So this is what the declaration, that is function declaration. So in the function declaration, I am passing array and I am returning a pointer. So here I am mentioning that I am returning an integer pointer. In the main function, what I am doing, I am having a pointer variable p and an array is declared and initialized with all these values. Let us see all the memory allocations now one by one. Then I am calling the function. So here what happens? For the main function, first of all, the memory will be allocated. So when you have a program, the memory will be allocated differently for different purposes. Say it will be allocated for all the instructions. First of all, for the main memory, that is the main function, we are going to allocate the memory. Then we have some stack memory, heap memory, and we also get memory for the local variables and global variables. So we are going to allocate the stack memory for this main function. So I have written this stack memory. So this is what the stack memory for the main function, and for the sub function also you are going to get the memory. Well, we have discussed about all these things in the previous videos. Please do check out. We have learned how the memory will be allocated for the program. Well, here in the function concept, we have discussed all those things. So you can just check out the list of functions topic. Now, so we have an integer pointer. So here I am going to get the memory for the pointer variable p. Well, it will have some address, something like 200. Pointer will also have the address. Now I say array. So array a, the array name represents as the constant pointer. So I am getting a means a is a constant pointer. Let me write the array here. So the values 10, 20, 30, 40, 50 will be stored here. Now I say the address is 100. So let me say 16-bit machine, 2 bytes, 104, 106 and 108. So this is the constant pointer. A represents the array name. So it is pointing to the base address, that is address of the first element. So here I get 100. So here I say A is pointing to the base address. The array name A represents as a constant pointer. It is constant pointer. Okay, so this constant pointer is pointing to the base address. So this address will be held in A. So A is pointing to the first element. Now I say return pointer. I am calling the function by passing the array name. Array name in the sense, as I said, it is going to act as constant pointer. It is going to provide the base address. So I am passing which value? That is, I am passing address. So this is function which is passing the address. That is passed by address, passed by reference. We have discussed with call by value and call by reference. Please do check out that video. This is call by reference, calling a function by passing the address. So I am passing the address, control goes to this. So here in the sub function, I am receiving this as A. So what we think? that it is one more array. So one more array will be created and all these values will come and store, and it will be stored here like this. No. This A will be interpreted by the compiler as a pointer. So it will be interpreted like int asterisk A. You can take some other name also, no issues. So here it is not an array. All the values will not be placed in new array, but the compiler is going to interpret this as an integer pointer. So here it will be interpreted as asterisk A. So now in the return pointer sub function I have A, where this A is receiving 100. So this pointer variable, so it is acting as integer pointer storing the value 100. Now A is also pointing to this location and this constant pointer also pointing to this location. Now what I'll do, I'll say, so this integer pointer A is pointing to the location 100 and this constant pointer also pointing to the location 100 base address. Now I'll say A equal to A plus 2. This is integer pointer arithmetic increment. That is, we are performing the pointer arithmetic. So A plus 2 in the sense A plus move forward by 2 locations, move forward by 2 elements. So it will be interpreted like A plus 2 into size of the data type. 2 into size of the data type, if I just say of integer, it is 2. So it is 100 plus 4, that is equal to 104. So now the value A gets this address 104. So A plus 2, we have dealt with pointer arithmetic. Please do check out the playlist. You have pointer arithmetic. You will understand how to perform the pointer arithmetic operation. That here we are doing the pointer addition, that is, we can say incrementation. A plus 2, that is just move forward by 2 elements, 2 locations. So it is A plus 2 into the size of the data type. So what is the size of the data type here? Integer, it is 2. So it is 104. Now A value is 104. Now here the A is changed. It is 104. Now it is not pointing to 100. It is pointing to 104. So when I say return A, it has to return 104 to the place where this function was called. So here, what is the value I get in P? It is 104. So now the P is updated here in the main function. Now P is also pointing to 104. Now when I say print an integer asterisk P, that is value at the location P, P is pointing to 104. What is the value at 104? It is going to print 30. So here the answer that what I am going to get is 30. 30 is my answer. See how I returned a pointer. Returning a pointer in the sense returning the address. Now when I return here, I can point to that location and access the value. But what I do, before I call this function, if I write it as A equal to A plus 2, then I say printf percentage D asterisk A. What will be the answer? No, you get an error because A here is acting as a constant pointer. Constant pointer cannot be changed. It will be always pointing to the base address. And if I just say A equal to A plus 2, it is wrong because constant pointer cannot be changed. But here when I say A, it can be any other variable name also, but here it is not the complete array that I am going to get, but it will be interpreted as a pointer, integer pointer. So this integer pointer can be performed with some arithmetic operations. So I can do pointer arithmetic. That's what I did here. Then I shifted to 2 elements. So here it is acting as integer pointer. I can do this. But here this is constant pointer which cannot be incremented. So hope you have understood with this program. Let us see how it is going to work. So let us understand this program. So we have the complete program here. Let us see how this program is going to work and how we can return a pointer from a function. So here we have the function declaration. So we say int asterisk means it is going to return a pointer, return pointer integer, array we are passing array. So in the main function, so we are passing the array values. So we have the pointer variable p, we have the array values initialized, and I'm passing this array a to the function that is return pointer. So return pointer, I'm sending the complete array a. So a in the sense it is going to send the base address, and this base address is received here in the function definition. So this is what with the function definition. So here this function definition header I have a. It means to say I am receiving the base address. So this array is acting as an integer pointer to receive that address. Now I say a equal to a plus 2. A equal to a plus 2 in the sense I am just trying to move forward by 2 locations. Then it is going to point to the location 30. So that address I am going to return. So when I say return a, it is going to return that address. So that address will be placed here in P. Then when I say asterisk P, it is going to print the value at that location. So I am going to get 30. So let us see how I am going to get the value 30. Now save the program and run the program. See, the answer is 30. So what is the answer? It is 30. Now let us try to add one statement here. So what I'll do before I call the function, if I just say a equal to a plus 2, then if I just say printf percentage d asterisk a. So a is actually a constant pointer which will be pointing to the base address. So array name will give you the base address, and if you try to change that, you cannot do the arithmetic operation on this constant pointer. So you will get an error. So let us save this and we'll see what output we are going to get. Execute this. See, it is saying error. Assignment to expression with array type a equal to a plus 2 is not allowed. So let me comment this. So I'll just comment this, then re-execute the program. Run this. So I got the answer 30. So hope you have understood how to return a pointer from a function. Returning a pointer from a function in the sense I am returning the address. So that is what. So returning a pointer means returning the address. So that's all for today's video. See you in the next video. Till then, take care. Bye bye.